Hello and good morning and happy Boxing Day, and welcome to this tutorial, which is going to be the third and final video of the three videos that we are going to be doing here on IPv6 over MPLS. And so far we've taken a look at basically excluding the provider from any participation at all with just simply an IPv6 over IPv4 tunnel. And again, the drawback there is that we can't have the provider do prefix delegation. If that was going to be required, they can't share with us some of their IP addressing space because, again, we're just simply doing a tunnel from CE to CE, and the PE routers really aren't involved at all. And then we took a look at 6PE, or 6 Provider Edge, which is where we have IPv6 peerings between the customer edge CE routers and the provider edge PE routers. And it's an IPv6 UNAWARE MPLS core. So again, in the core, and that's going to be the case here as well with 6VPE, is the core. There is no IPv6 in here at all. Remember, this is all going to be following a label switched path, which allows us to tunnel with MPLS because we're going to have those MPLS labels imposed or on the prefixes that are going to be exchanged back and forth as they switch through this MPLS IPv4-only core. And so that was 6 Provider Edge. Now the key with 6 Provider Edge is the other big difference. You have that IPv6 direct peering with the Provider Edge router if you're the customer. And the second major significant difference is that you are in the global routing table for the provider with 6 Provider Edge. So if you don't want to be in the global space, you need to be in the VPN space, right? Or the 6VPE. And 6VPE is a little more like what we see when we do the traditional IPv4 MPLS L3 VPN. So we're going to have a VRF on the interface for the peering with the customer edge router, and that's going to be on both sides. And in that VRF, we're going to have our route distinguisher defined, as well as our route target information. And then we are going to go ahead and set up a VPN v6 iBGP peering here. So this would be VPN v6. And again, remember that the core is still all IPv4. And so it's IPv6 UNAWARE. And so between 6PE, let's put 6PE over here and wrap up sort of the compare and contrast, and 6VPE, right? So over here there are no VRFs, and you're in the global routing table. And with 6VPE, and that's exactly what the V is telling us, is that we are going to be setting up VRFs just like we would with a traditional IPv4 MPLS L3 VPN. And you're not in the global table, that you're going to be in your, and we'll just put the customer routing table. So again, it's going to be your own sort of private space in here, just like it would be with an MPLS L3 VPN for IPv4. And so these are the significant differences between 6PE with no VRFs and the global table. And when I say no VRFs, specifically no VRFs that are IPv6 VRFs. You could do IPv4 peerings at the same time, but we're talking about IPv6 here. So no IPv6 VRFs are going to be set up, and you're in the global routing table. 6VPE is we are going to have VRFs, and you'll be on the customer table. And again, so let's talk about between the PEs. Another difference would be that the PEs are going to be peering in the VPNv6 address family, whereas over here, since we're talking about the global routing table, you are in the address family for IPv6 Unicast. So not tied to a VRF, right? So when we look at 6VPE compared to 6PE, those are the significant differences. And again, we're not too far from the sort of the final overall solution here. If you think about the things that need to be done, number one would be we need to have this IPv4 MPLS core configured with LDP, and we've got that, and that's running. And then we're going to set up the VRFs, right? I'm looking here at my photo. We're going to be setting up the VRFs here. After the VRFs are set up, we'll set up the peerings, and we're just simply going to use eBGP. Now, eBGP. Now, you could use EIGRP or OSPF or RIPNG, but we're going to keep it simple. We're going to avoid that mutual redistribution that would have to take place on the PE if we're using a routing protocol other than eBGP. And then once that's done, you set the VPNv6 relationship up here, right? So we've got that exchange of labels that's going to be taking place. And then again, if we were redistributing, we would redistribute EIGRP into BGP or OSPF into BGP, and then vice versa. But we're not going to do that. We're just simply going to stick with eBGP for our peerings here, and that's going to keep it pretty straightforward. So again, 6 PE, no VRFs. It's your routing information is in the global space, and when you do the peering between the PE routers, let's put the PE peering here, you do IPv6 unicast, and then you use the IPv4 address, whereas over here with 6 VPE, we've got VRFs. We've got the customer with their own little private routing space, control plane. And then we've got the PE routers are going to be establishing their peering over the VPNv6 address family under BGP. So let's dive in here. We're going to have a little cleanup to do because nothing has changed from the previous configuration. So for the customer, not much is going to change. So what do we need to do first? Well, we need to set up the VRFs between the CE and the PE router. So let's, or I should say the VRF on the PE side for the CE router. So let's go from user exec to privilege exec in the global config and say do show run VRF. So we have this here. Let's do this. Let's start from scratch. So let's say no VRF definition customer A. And so we'll recreate it again. And you can see here it says IPv4 and IPv6 addresses from all interfaces in VRF customer A have been removed. So let's check and see what do show run interface serial 010. So we still have, we still have our information there, and that should be the correct interface. Yeah, serial 010, and then let's take another quick peek here in serial 010 on router 3 as well. All right, so we didn't lose any information there because, again, when we're doing 6 PE, right, 6 Provider Edge, there was no VRF information. Right, so now let's recreate that again. So VRF definition, and we'll just say it's going to be customer A. Now, we've got to wait for the deletion. Okay. Whoops. So there we go. Okay. So we had to wait for it to clean things up. So now that everything is cleaned up, we're going to come in here. We're going to say route distinguisher. And for this customer, we'll just use 1:1. Now, what's very important is when I do the question mark here, you'll see that we've got the route target information that we could set up. Now, when I specify the route target here, it's going to apply to each address family that we create. If you wanted to do something more specific under the address family, then you could do that. But make sure you go into the address family, right? We have to go into the address family. So we say address family IPv6, and then if I do a question mark, you can see the route target statement is here as well. Now remember, this is going to be that BGP extended community attribute that's going to be exchanged between the Provider Edge routers that's going to tell us into which VRF am I placing the traffic. And so let's go ahead and set it up here. So we'll say route target, and we're going to do import and export both. We'll keep it straightforward here, and we'll simply say, what is this? So this guy is, we'll use this, I guess we'll just stick with the same thing. We'll say 1:1. So route target both 1:1. So when I say do show VRF, right? So customer A is the name of the VRF. The route distinguisher is 1:1, and we've got it set up for IPv6. Again, remember, with 6 VPE, the PE router is still dual stack because it's participating in the existing MPLS IPv4 provider core infrastructure, and it's also interfacing with the customers. And again, the use case here is that the customer says, hey, we want to roll out IPv6, and maybe it's a greenfield environment, and we don't want our IPv6 routing information in the global table. We want it cut off. We want it segregated, right, in its own little hermetically sealed bubble inside of the provider network so that no one else can see our information. So that's when we bring in the VRF configuration. So let's say do show run section VRF, and I can actually just cut and paste this. So here's what we're going to do. We're going to grab the VRF definition customer A. We're going to copy that, and let's drop it over on the other PE router. And I think what we need to do first is, let's say, show run VRF. I think we have the same thing over here. We do. So let's get into global config, say no VRF definition customer A, and that's okay because we weren't doing any VRF work there. So let's paste in the new definition. Oh, we're waiting. All right, so we're still waiting for the deletion of the VRF. Yeah, still in progress here. So we'll give it a couple more seconds. Actually taking a little longer than I'd anticipated. So there we go. So now we've got the same VRF definition on both sides. All right, so we've got the MPLS IPv4 core. We've got the VRF configured on, well, I guess the VRF is configured on the provider edge routers. Now, remember, we need to apply the VRF on the interfaces that are facing the customer. And that would be, again, both serial 010 on both router 2 and router 3. So let's place those into the VRF. So let's go into interface serial 010. And before we do that, very important that you say do show run and the interface you're going to be placing it on, because watch what happens when I say VRF forwarding customer A. It not only, even though we're only doing the address family for IPv6 in the VRF, it wiped out do show run interface serial 010. It's wiping out all of the IP addressing. So again, irrespective of the fact that we're just doing IPv6, it's taking all the IP addressing information off of the interface. But again, very simple, very easy for us to add that information in as long as we have done the show run interface serial 010. All right, so now what does that interface look like? So do show run interface serial 010. Now this is on the provider edge router. So you can see we are in the VRF forwarding for customer A. We've got all of our IPv4 and IPv6, even though we don't need the IPv4 information, it just got pasted in there. So, but we've got that IPv6 information that we're going to need. So now let's drop over to router 2 and let's do the same thing. Let's apply the VRF definition to the interface into which customer A is connecting. And again, we're doing this because they want to make sure that none of their routing information shows up in the global provider table. So do show run, interface serial 010. All right, so again, very important that we see what is configured, 010, what's configured there, and we're going to say VRF definition, or forwarding, VRF forwarding customer A. All right, so again, IP addresses have been removed. You can see our adjacency goes down. So now let's grab that information that we lost and drop it in there. So what does it look like? Do show run, interface serial 010. And there we go. We've got the VRF forwarding customer A. We've got the IPv4 address, which again, irrelevant with what we're doing here. We've got the IPv6 addresses, and those are the important ones that now sit in the customer VRF. Now, one thing you'll notice is we had the BGP session flap, right? And it went down. Because again, we had a BGP peering, an IPv6 BGP peering that we were doing when we did the 6 provider edge. But again, the significant difference, or one of the significant differences between 6PE and 6VPE is that there was no VRF in play with 6PE. So on the provider edge routers, all of the customer information for customer A was in the global routing table. In fact, not only was the routing information in the global routing table, remember the BGP peering statements, the configuration for BGP was also set up in the global BGP config section and then in the IPv6 address family section. So let's take a look at that. Do show run section BGP, and we should still see here. I didn't remove anything, and yeah, so take a look here. So here is the neighbor statement, and this is definitely something that could trip you up to give you the impression that, yeah, why is that BGP peering not working? Because I've got the neighbor statement here in the global config section, and I have it down here activated in the IPv6 address family. So it should be working, but it's not. Remember, the reason it's not working here is because the Provider Edge router has placed the interface that the customer's connected into. It's not in the global routing space anymore, right? It's in its own VRF. So if we want to see those peerings come back, what we need to do is on both Provider Edge routers, we need to go in and create a we need to go into both Provider Edge routers and create a VRF-aware BGP config section, because that is how we're going to bring the peerings back up with the customer edge routers on both sides. This is no longer going to work. In fact, if I say do show BGP IPv6 summary, you can see, take a look at the statement right there. It's idle, right? So take a look at the neighbor statement for, and this is, we're on router 2 PE1, which is directly connected to router 1 for customer A, and you can see that it's idle, right? So we're sitting here in the idle state because we've got this definition here, but in the IPv6 address family and in the global BGP config section, however, that's irrelevant because we've now placed that interface into which customer A is connected to router 2 PE1 into a VRF. If we go to router 3, we're going to see the same thing. If I say do show BGP IPv6 Unicast summary, again, just as you would expect, we are idle over here as well. And the reason that it's idle is because it can't communicate with the customer edge router for customer A, with either of them, because the interface into which the customer has been placed is now VRF aware. So how do we solve this? Very simple. So we'll say router BGP1, and we're going to say address family IPv6 Unicast, and I think we get our VRF definition here, and then we say VRF customer A. So what we're doing is we're going to address family IPv6, but we're making it a VRF aware. So now I'm telling the Provider Edge router that you need to understand that the interface into which this peer is connected is in VRF customer A. And so now BGP says, oh, okay, so on the interface where I've defined VRF forwarding for customer A, that's how we're going to communicate here. That's kind of stitching the VRF to the BGP process, making BGP VRF aware. So then what do we need here? Well, the same statements that we would have in the global space, and I can never remember the IP addresses. Where are we at? Or it's too far up. I thought I displayed that a second ago. Here, let me do this real quick. I can't remember. Do show run section BGP. I want to get my IP addresses here real quick. So we could actually probably just cut and paste. So we'll say neighbor 2001 DV8 :3737 ::7 remote AS is 65432 right? And then we just simply pull that back. And remember, this is all taking place inside. Oh, and it did the active. So I was backing up to do the activation, but it looks like the 15.3 code has done that auto-magically. Let's check and see. So do show run section BGP. So I did the command under the VRF, and take a look at that. It activated it auto-magically for me. Now, good housekeeping is going to tell you, when, excuse me, do show BGP IPv6 Unicast summary. Good housekeeping is going to tell you that, hey, you know, if you're not using this as in the global the global VRF, we'll call it, this peering here, then we should probably pull that peering out, right? Because we're going to see that. Someone could see that and think, oh, we've got some kind of an issue here, where in fact, it's really not a problem at all. We've just done it inside of a VRF. So let's go ahead and in good form, we will clear this up. And I'm simply going to say no neighbor. Let's grab that right there and copy and paste. And we'll pull that out. And so now what do we have? Do show run section BGP. So we've got that cleaned up. And yep, it pulled it out of the address family, right? There was a statement here that activated it. It pulled it out when we did the removal of the remote AS command in the global BGP space. So now we've got customer A activated here under the VRF for customer A. So now let's take a look at that command that we see again. So that idle peering should have gone away. But now let's say do show, and I'm going to go down to... let's see, let's go all the way down to end. Let's say show BGP IPv6 VRF, or actually Unicast, sorry, VRF. No, do show BGP VRF. I can never remember. That's why I have to go to the context-sensitive help. Yeah, so customer A, and we'll say all. Oh, sorry about that. Show BGP IPv6, and where is the VRF? Let's see, this is only going to show me that. I want to see what's in the VRF. Show BGP, I can never remember the context. VRF scope. Let's just do the asterisk here. We should see that. Show BGP. BGP VRF IPv6 all, and it's not giving it to me for all address families INSAP. Give me a second here. Show BGP. I'll say all address families. But we lose the VRF. So what I'm trying to do here is display only the information in the VRF. And I can't remember. Should be for all, and then summary is what. There we go. All right. Yeah, I got to get the command straight in my head. So show BGP VRF. And actually, no, I apologize. This is not what I'm looking for. I'm looking for that same command. Show BGP, oops, BGP IPv6, but then it pulls away the VRF option from me. VRF, if we did them all, and I want to see IPv6, VPNv6. We don't have the VPNv6 adjacency up yet, and this is not going to do it. Yeah, I'm struggling here trying to remember how to see that peering. So let me check it over here on router 7 side. Yeah, so the peering is up, but we need to be able to show BGP IPv6 Unicast. So there's my NLRI that I'm originating, summary, and there's the peering. So the peering is up, but we need to remember, I'll have to come back to this, see if I can jog my memory here, because yeah, it's a little quirky. The command to see it, and it's not the VPNv6 because we haven't done that yet. I was just wondering if it would show me something different, because the command that we want is this command, but for IPv6. All right, we'll continue on here because we see the adjacencies up, but I'm going to come back to this because I want to sort that out. All right, so we've got it all set up here. So show run section BGP. You can see that the BGP section is all set up. Everything looks good, right? And so this is all good. So now what we're going to do is we're going to do the same thing over on router 2. So do show run section BGP. So we take a look here, and you can see that we've got sort of the same challenge that we had before, where we've got that global statement. So let's get into router BGP 1, And let's do the low-hanging fruit first. Let's just wipe out this neighbor statement here. Say copy and paste. All right, so that pulls out the 6PE peering, and so that's taken care of. And so now what we want to do is we want to create that address family IPv6 Unicast VRF customer A, and it's within the VRF, the VRF-aware BGP setup that we have here, that we now come back with the neighbor, and I've got the address right up there above me, 2001 DB8:1212::1. Let's get that remote AS in here, 65431. And it should activate it, so do show run section BGP. Let's see if we can get the section up here before it. Yeah, and it auto-magically dropped in that activate statement for us, and the peering is back up. Again, this is how I'm telling you that the peering is back up. We've just seen the message pop up. I'm still not remembering the command to run that for to see that printed out there. All right, so the peering is back up. So we've got the MPLS IPv4 core. That's already been done. We've got the VRF set up, defined and set up between the customer edge router, or I say the provider edge router, and the customer edge router, and our peerings are up. The PE to CE routing protocol, we're using eBGP, so there's no need for me to redistribute eBGP into eBGP and vice versa, right? It's going to naturally take place, and this is obviously the easiest way to approach this. Now, the final thing that we need, and if we take a look at the customer edge routers right now, am I picking up any routing information? Show IP or show BGP IPv6 Unicast. Am I getting any routing information from router 1 out there in Los Angeles? Right? No, I only see the locally originated NLRI, right, which is that loopback 0 address that we have the network statement for here. We don't have anything. So if I step back over to the provider edge router, let's get into global config, router BGP1, and what we're going to want to do here is drop in a network statement. I just realized the network statements are not in there. So address family IPv6, VRF, customer A, customer A, and if we were to add the network statement in, I'm sorry, not on the PE router. No, that's right. So we are, okay, we're good. I'm sorry. Went back to the PE router, but we're not going to actually be advertising anything here. So we should be good. So now what we need to do is we need to configure the peering between the PE routers. Now before, remember, we use the IPv4, not the control plane, the IPv4 transport in order to deal with and facilitate the exchange of the IPv6 information, right? Which is why under the address family for IPv6, we're listing IPv4 addresses for the peering. And we also sent the label. Now we had BGP take care of the label for us. What's going to happen here is that we're going to get a VPN label as well, but it's going to be the VRF that's going to be taking care of that labeling for us. So we can leave these in here, right, if we wanted to, and all we need to do now is get into the address family not IPv6, address family VPNv6 and Unicast. So now we're going to be doing a VPNv6 peering between, and once again, we're using the IPv4 addresses. So I'm going to say neighbor 2.2.2.2 not remove private AS. And it's actually not, I think we just need to activate, is that right? Yeah, I should just need to activate here. Let's see if that is do show run section BGP. Yeah, so the capabilities exchange is going to take place because now we're going to be saying we can do VPNv6 information, and very important here, send community extended. If I don't do this, then we're not going to be able to communicate those VPNv6 labeling information that's going to be required. So we need to make sure we have send community extended. In fact, these statements here are no longer in play for what we're doing because, again, this was in the global space. And so there's not even going to be a peering with those addresses anymore, or I should say, in the global space. We're doing it in the VPNv6 space. And we'll remove that on this side here. So let's jump out here, say do show run section BGP. So we see the BGP section, and we're going to say address family VPNv6. Unicast, neighbor is going to be 3.3.3.3, and activate. And you can see here, again, capabilities have changed. So let's see what the capabilities look like. So do show IPBGP neighbor. Actually, do show BGP. Sorry about that. BGP VPNv6 Unicast. And it should be Unicast neighbor. Let's get down. Show BGP VPNv6 Unicast all. There we go. Neighbor. Unicast all neighbor. All right, and so let's take a look here. So we had the IPv6 address family for Unicast. Remember, the IPv6 MPLS label capability was still there, but now we have this new capability. Address family VPNv6 Unicast has been advertised and received. So let's come over here and actually let's remove the address family IPv6 Unicast. We want to say no neighbor 3.3.3.3, because again, we don't need the IPv6 global peering. We need the VPNv6. So all I've done, do show run section BGP. I should have done it on the other side as well, but we just did it here. And you can see that for IPv6, we've got the VRF definition for the customer, but the address family for IPv6, it's gone, right? So our VPN adjacency is up. So VPNv6 adjacency is up between the two PE routers. All right, so now we should be able to come over to customer A here in Los Angeles and say, show BGP IPv6 Unicast. And do we have the information for the prefix 7777, right, over on router 7 in New York? We do, right? And let's take a look over on router 7 and see what we've got. So we say show BGP IPv6 Unicast. And we do. Do we have reachability? Let's see. If I were to say ping 2001 DB81111::1, source it from my loopback 0 address, and take a look at that. Now, one of the key things, right? Let's talk about the differences. Back on the PE router, if I say show show IPv6 route, do I have any of the information for the customer here? I have none. There's no customer information in the global IPv6 routing table because we've tucked it away into a VRF. So then the question is, well, how do I see that information? So let's say show BGP IPv6. Oops, sorry. I'm sorry, not show BGP. VPNv6. I always forget the VPNv6. Address family, Unicast all. So in VPNv6 Unicast all, take a look. This is where I see the information, right? And we can see here the default for customer A. We've got our route distinguisher information, and it's valid and best. But keep an eye here. Remember, we're still going over the IPv4 transport, right? So the passenger protocol is IPv6, and throughout the core is still MPLS unaware. And so this is what stitches the next hop value, which is an IPv4 address from our router 2 Provider Edge router. This is how we stitch together how we're going to get to that next hop. So we see the 3.3.3.3, and we know that there's going to be a label involved here. So if I were to say show BGP VPNv6 Unicast and all, well, let's like keep it to, well, actually we'll just go all Unicast all. And if I were to do the 2001 DB8 1111:1/64. All right, so you can see here that the MPLS label in is going to be 203, and this is the 1111. That's actually, let's change it also to the 7777. 7/64. And missed my second colon there, 7/64. There we go. And so from provider edge 1, which is router 2, right, we see that label again. That outbound label is going to be 306. And here is that IPv4 embedded address into an IPv6 address. And this is what gives me the next hop. And then that's how things are stitched together in terms of this provider edge router knowing what is the next hop. And it's got the label value that it knows it's supposed to throw on there. And so then it's going to know, excuse me, how it's supposed to forward that traffic. So if I were to say show MPLS forwarding, right, I know how I'm supposed to get to that next hop. Is I'm going to put this outgoing label on there, right? And it's going to get sent over to 3.3.3.3, and that is how that traffic is going to be sent across the MPLS network. In fact, if we did a Wireshark packet capture right now, so let's kick that off, say continue without saving, we'll come over here, go back to our ping command, which we didn't have in there, so we'll say 2001:db8:1234:7. We'll source it from our loopback 0 address, and there we go. Let's stop things here. So here are those pings that we just sent. Let's take a look. Let's fold this up here a little bit. Right, and again, we take a look at what we have. We've got the layer 1 information, right? Here are the bits and bytes that are on the wire. We've got our layer 2 information. Now, remember, what should we see in here? Because this is being captured between the provider edge 1 router and router 11 in the MPLS core. Exactly. We see that it's an MPLS label switched packet with ether type 8847. So here is the top label, which is the 1100, because that's the one that's going to be imposed or pushed onto this packet as it goes between router 2 and router 11, which is, again, 11's in the center of that setup. The bottom label is our VPN label, right, which is going to be label 306. And then we've got our our IPv6 information, which is our layer 3 information, right? And you can see we've got the source destination information. Everything is in here that we need. And then finally, the layer 4 information, that ICMP-v6 information, and this is just an echo request, right? So very, very similar to everything that we've seen prior to this in terms of the labeling that gets done and put onto the stack. All right, well, this is going to wrap up the IPv6 over MPLS migration topics. And again, we looked at simply doing an IPv6 tunnel over the existing L3 VPN, which was MPLS L3 VPN, which is IPv4 only. So we just set up a tunnel, taking the provider out of the equation. Then we looked at 6 provider edge, which is you're going to be in the global routing table. You're not going to have a VRF. And then we looked at 6 VPE or VPN provider edge, which is where we do have a VRF. Your routing information is not going to be in the global routing table of the provider. We set up the route target, route distinguishers, the VRF definitions, and the VPNv6 peering between the PE and CE router. And again, as soon as you start dealing with VRFs and IPv6 in this scenario, that is 6 VPE, remembering that 6 PE had no VRFs, right? There were no VRFs. And the peering between the PE routers, we used BGP to send the label instead of using LDP to make that labeling happen. All right, well, thank you so much for watching. Hopefully this has cleared up the IPv6 migration strategies that we've talked about, and you've got a better understanding of how you can take IPv6 and implement that into your environment, leveraging the existing IPv4 MPLS provider core network that you might be hooked up to. All right, thanks a bunch. Happy Boxing Day, and have a great day.